Namaskar friends, I welcome you all in this class of mathematics. So, in last class yesterday we were discussing combination. We are discussing the chapter the techniques of counting, in which we have already seen permutation. Yesterday we have discussed combination, and today we are going to discuss binomial theorems. So, something was left in combination, so let me finish it first. Combination. So, if out of n distinct things there are r things to be taken together at a time, then yesterday we discussed that its formula is factorial n divided by factorial r divided by factorial n minus r. So, you should remember this formula, and then we were discussing inclusion and exclusion. So, suppose from n distinct things, r things are to be taken at a time, and maybe s things x things are to be always included. So, this s should be greater than 0 and it should be less than r. So, in this case let us first consider the permutation. You know, permutation is important when order is important. Order, we are concerned with the order of the things, then we take permutation. So, let us say if S things are to be always included, how many number of ways we can select out of n things R things to be taken. Condition is that S things should be always included. So, this will be, first we will take S things, because this has to be included always, and this has to be permuted at R places. You see, R places are there, and there are S things to be placed. So, this can be done in RPS manners. Okay. So, that S vacant places can be chosen from R places in permutation in RPS ways. So, it will be RPS multiplied by, because simultaneously then rest of the places are to be also filled. So, now the number of things remained, distinct things, will be n minus s, because we have already taken s things at in the R places. So, from the remaining n minus s things, we can arrange things at the remaining places. So, remaining places will be R minus s, because we have already filled s things. So, the remaining places will be R minus s. So, this will be the number of permutation, number of ways in which we can arrange R things taken at a time from the n distinct things, and the condition is that S things are to be always included. Now, the next condition for exclusion, suppose that S things are always excluded. So, what will be the number of ways in which we can arrange the things? That is, in this case, NPR will be equal to, since S things are to be always excluded. So, we have only n minus S things to choose with, because S things are to be included. So, we do not consider S things as our input set or domain. So, this will be n minus S P, and we have to choose R things. So, n minus S P R, isn't it? Because S things we have excluded, we do not have to select. So, only out of n minus S remaining distinct things we choose R things, that will be equal to N P R. So, let us take what happens in case of combination. Suppose the order is not important, only grouping is to be done, then what will be its formula? So, if order is not important, then we have to find out NCR, that how to select, in how many ways R things may be selected in a group out of n distinct things. The condition is that S things are to be always included and S is greater than 0 and less than R. So, first we select S things and put it in the group, and then from the remaining n minus S things, we make group of the remaining things, say R minus S. Since here grouping is important, arrangement is not important. So, S things we have selected, there need not be any other arrangement for that. In the case of permutation, we permuted out of R things, R places, how from S things it will be filled. So, RPS was coming here, but here it is not required because this is a grouping. So, order is not important. So, this will be the formula, and the second one, is that S things are to be excluded, always excluded, This is easy because which are to be always excluded, you do not consider them as your domain. So, this NCR combination will be equal to, just as in the case of permutation, this will be equal to, we do not consider S things. So, we have to choose only out of n minus S things, and we have to choose all the R things, because nothing has to be filled out of these S things. So, this will be formula n minus S C R. Now, let us take an example. Let us take a problem. Suppose a team is to be selected from a squad of 11 players. We have to select from a squad of 18 players, we have to select 11 players. (18 players squad is there, 11 to be selected, out of these 3 players, now the first question is 3 players are to be always included. You see, just as we select in a cricket team, say 3 very good players are there. So, their seat is fixed, they will not be disturbed. So, in how many ways? Here grouping is important because order is not important. So, we will select out of, we will first select the 3 players which are anyway to be included. Okay. So, these 3 players will be selected, and then the players, remaining player will be 15. So, we have to select 11 players from the 18 players, but 3 players we have to include necessarily. So, from the remaining 18 minus 3, we have to do grouping of remaining players, because 3 position we have already filled. So, we have to now fill only 8 places, that is 11 minus 3. Say for a World Cup team, captain, vice captain and one more player, say Rohit Sharma and KL Rahul and then Virat Kohli. So, these are fixed. So, they will come in any way. Now, from the rest other 15 players, how many groups can be made for remaining 8 places? So, this will be equal to 15C8, which will be equal to factorial 15 divided by factorial 8 into factorial 15 minus 8, which will be equal to factorial 7. So, you can calculate. Now, the second question, that out of this squad 2 players are injured. So, we have to exclude these 2 players. So, the condition is that we have to select 11 players out of 18 players, out of which 2 injured players are there. So, we have to exclude them. So, in how many ways we can form the groups? So, this will be equal to 18 C11 which is equal to, since 2 players are injured, so we do not consider 2 players as our domain. So, it will be 18 minus 2 C11, because we have to select all the 11 players from the remaining 16 players. So, it will be 16 C11, that will equal to factorial 16 by factorial 11 by factorial 16 minus 11, that is equal to 5. So, you can calculate now. Now, the third we can consider that both the conditions that always select 3 players and 2 players are injured. So, 2 players you have to exclude, both the conditions are there, then what will be the number of ways? I mean, out of 18 player, we have to select the team of 11. So, that will be equal to, now since 2 players are injured, so we will consider only 16 players are there. So, it will be 16 and 3 players we have to select anyway. So, we select the first the 3 players, then there are remaining players will be 11 players are to be selected. So, 3 we have already select, the remaining position will be 11 minus 3. So, this will be equal to 16 C 8. Factorial 16 divided by factorial 8 into factorial 16 minus 8 will be 8. So, now you can solve. So, now this completes your inclusion exclusion problem. Now, let us see the binomial theorem. Okay. So, binomial, you already may be knowing, must be knowing that if there are in any expression 2 terms are there, we call it binomial. If only one term is there, that is mononomial, and if 3 terms are there, we call it trinomial, and there are many terms, then polynomial. So, binomial means that 2 terms are there. So, a binomial theorem for positive integral index. Okay. Binomial theorem is very important theorem, and it will be used at many places in your courses. Quite useful. So, suppose positive integral index. It means that suppose there are two terms and its power is n exponent. So, this exponent n is positive integral, that is what it means. So, the proof of this theorem is not in your course. So, I will only write down the expression, and it is not difficult. I think it is easy to remember, and I will tell you how to remember it. So, its expression is n is here. So, we start from n c 0 and then a to the power n into b to the power 0. Now, the next term will be n c 1 a to the power n minus 1 into b to the power 1. Next term will be n c 2 a to the power n minus 2 into b to the power 2. Next term would be n c 3 a to the power n minus 3 into b to the power 3. So, you see there is a pattern, and this pattern is not difficult to remember. At the end it will come the last two terms I am writing n c n minus 1 a to the power 1 and b to the power n minus 1. Last term would be n c n a to the power 0 and b to the power n. So, this is the formula. It is not difficult to remember, because you can see it starts from n c 0, and this is called binomial coefficient. These are all binomial coefficients. Binomial coefficients. So, you can see binomial coefficient very systematic n c 0, n c 1, n c 2, n c 3 till n c n. Now, the two terms are there a and b. So, we start with a n and b 0, and then successively we go on decreasing a n minus 1 by 1 and then increasing b by 1. So, whatever the subscript here at C, it will come at the superscript of B. Again n c 2 a n minus 2 b square. So, only by looking 2-3 times you can understand the pattern and remember the formula. So, let us take an example. Okay. So, example is x plus 1 by x to the power 5. So, now you can do its binomial expansion. It will be equal to, say we start with n c 0, n is 5 here. So, 5 c 0 and then x to the power 5 and 1 by x to the power 0, which will equal to 1. So, I am not writing here. Now, next term will be 5 c 1 x to the power n minus 1. So, x 4 and 1 by x to the power 1. So, 1 by x will come here plus 5 c 2 x cube, because n minus 2 will be x cube into 1 by x square. So, it will be 1 by x square plus 5 c 3, it will be x square, because the power of x is decreasing successively and this is increasing 1 by x cube plus 5 c 4 x to the power 1 divided by 1 by x 4 plus 5 c 5 x power 0 will become 1. So, it will be 1 upon x to the power 5. So, this is the binomial expansion of this x plus 1 by x to the power 5. Now, let us, you can calculate 5 c 0, 5 c 1, 5 c 2. It is easy. You can 5 c 0 will be equal to, yesterday we calculated that N C R is equal to N C N minus R. We proved it. So, 5 c 0 will be equal to 5 c 5, which will be equal to factorial 5 upon factorial 5. So, it will be equal to 1. 5 c 1 is equal to 5 c 4 will be equal to factorial 5 divided by factorial 4, which is equal to 5. 5 c 2 is equal to 5 c 3, which is equal to factorial 5 divided by factorial 2 into factorial 3. So, this will be equal to 5 into 4 into factorial 3, should cancel it out. So, 5 into 4 by 2, which is equal to 10, and now we have done all, isn't it? Because 5 c 4 we have already taken here and 5C1 we have already taken here 5C0. So, if we put all these things here, this expression will become this way 5C01. So, it is x5 plus 5C1 is equal to 5 and x4 divided by x. So, it will be x cube plus 5C2 is equal to 10 x cube upon x square, it will be x plus 5C3 is equal to 5C2. So, it will also become 10 and x square upon x cube. So, it will be 10 upon x, and then 5C4 will be equal to 5 x upon x4. So, it will become x cube, 1 x will cancel out here, and then this is equal to 1. So, it will be equal to 1 by x to the power 5. So, this is the final expression for the expansion x plus 1 by x to the power 5. Now, we can see a couple of more examples, but let me first finish, and then at the end we will take examples, because there will be shortage of time. So, first I will write the expansion of other type. And then we will take examples. Now, suppose binomial theorem for any index. See, we have seen this binomial theorem for positive integral index. Now, let us take for any rational index. So, what is the expansion? Suppose here I am not writing a plus b, I am writing it 1 plus x n, because a plus b you can convert it in the form of 1 plus x to the power n, and this expansion is 1 plus nx plus n into n minus 1 by factorial 2 x square. You can see that a systematic pattern is here. So, it is not difficult to remember this expansion plus n into n minus 1 into n minus 2 by factorial 3 into x cube, and it will go on, and I am writing the rth term, that will be equal to n into n minus 1 into n minus 2, it will go to n minus r minus 1 divided by factorial r into x r, and it will not stop here, it will go on, because if n is not a positive integer, so it will go till infinity, and this sum will be finite only if it is valid only if mod x is less than 1. Otherwise, its sum will be infinite. So, this is the formula. Now, suppose that you have a binomial a plus b to the power n for any rational index. So, what are you going to do? A plus b so suppose that in A and B, suppose that A is greater than B. If A is greater than B, then you take A outside, so it will be equal to A n 1 plus B by A to the power n. So, in that case B by A will be less than 1, isn't it? So, its expansion would be this A n we can take outside, and within brackets 1 plus x to the power n expansion we know. So, we will write 1 plus n into b by a plus n into n minus 1 by factorial 2 into b by a square and plus 8 into n minus 1 into n minus 2 divided by factorial 3 b by a whole cube, and plus it will go on. But since b by a is less than 1 mod of b by a, so this sum will be finite. And suppose the case is that if b is greater than a, in that case what we do, that we take b outside. Since b is greater, so we take b outside and it will be 1 plus a by b to the power n, and mod a by b will be less than 1. So, its expansion will be, similarly we can expand it, it will be equal to b to the power n we take outside and 1 plus n a by b plus n into n minus 1 by factorial 2 a by b square plus n into n minus 1 into n minus 2 by factorial 3 a by b cube, plus we can go on writing the terms, and as we, since a by b, mod a by b is less than 1, so as we go on increasing, its value will be become smaller and smaller, and after some time we can truncate and we can take its summation. So, now we will take say one example, we have time. So, let us take the example (7 plus 2x minus 5). Okay. Let us quickly take one example here, so that it will be clear to you. We can take any fraction also in the exponent, it should be rational, that is all. So, similarly we can do, and we can take examples of fraction also. So, 7 plus 2x, 7 plus 2x to the power minus 5. So, this we can write 7 to the power minus 5 I have taken outside, and here it will become 1 plus 2 to the power 7x, 2 to the power 7 into x to the power minus 5. This will be valid if 2 to the power 7 2x by 7 mod should be less than 1. It means that mod of x should be less than 7 by 2. So, this is the condition. So, now this expansion will be 1 by 7 to the power 5, and this will become 1 plus 2x. So, this will become 1 plus n minus 5 into 2 by 7x plus minus 5 into minus 5 minus 1 divided by factorial 2 into 2x by 7 square plus minus 5 into minus 5 minus 1 into minus 5 minus 2 divided by factorial 3 2x by 7 cube and plus it will go on increasing. Now, friends, the point which I want to make here, that these binomial coefficients, this will never become 0. So, it will not, it will go till infinity, it will not be in the case of positive index it becomes 0. Why it becomes 0 at after n? Because when you come to n minus n, it will become 0, and then afterwards all the terms will be 0. But here it will never become 0 because this is minus index, and you go on decreasing minus 1, minus 1, minus 1, and minus 1, minus 2, then minus 3, minus 4. So, it will go to minus infinity, and this term, this binomial coefficient will never be it will be equal to 0, but the only thing that if mod of x is less than 7 by 2, so this term will less than 1, and its further power will go on decreasing, and the terms will become smaller and smaller. So, then it is easy to find its sum. So, now you can simple mathematics is there, you can do, and you see you must have understood that how we do the binomial expansion, and in lot many courses you will come across such cases where you have to use these binomial expansions to solve many problems. Thank you very much. Thank you.